Good evening, friends. Today we will talk about the topic 2D translation from computer graphics and visualization. Starting with the topic 2D translation. Here we will take things into four parts: introduction, 2D translation, 2D rotation, and 2D scaling. Introduction. 2D transformation is a process of changing the position, size, orientation, or shape of an object in 2D plane. It is fundamental concept of computer graphics and it is used to manipulate images, animation, and other graphic content. There are many different types of 2D transformation, but one of the most include translation. This is a form in which we move an object to a new location in the 2D plane. As it is visible in the image, PXY has been changed to another position on the XY plane, and its new position is X1 and Y1, and the name remains same, P. Continuing ahead, scaling. This type of transformation changes the size of an object. It can be used to make an object larger or smaller. Rotation of this type of object can rotate around a point in a 2D plane. Talking about shear, this type of transformation stretches or compresses an object along a particular axis. The axis could be x-axis, y-axis, xy-axis, z-axis, not z-axis because we're talking about xy plane. 2D translation. 2D translation, we perform translation on a single coordinate point by adding offset to its coordinates, generates a new coordinate position. We are moving the original point along with a straight line along to its new location. The translation translates its position. We add translation distance tx and ty to the original coordinate x and y to obtain a new coordinate position x dash and y dash as shown in figure. The translation values of x dash and y dash is calculated by the distance pair, which is tx and ty, called the translation vector or shift vector column. Its representation is given as x dash and y dash. This allows us to write 2D transformation translation equation in the matrix form. Translation is the rigid body transformation that moves object without deformation. Here we talk about 2D scaling, two-dimensional rotation. We generate a rotation transformation of an object by specifying a rotation axis and rotation angle. A two-dimensional rotation of an object is obtained by repositioning the object along a circular path in the xy plane. In this case, we are rotating the object about a rotation axis that is perpendicular to the xy plane, parallel to the coordinate z-axis. Parameters for the two-dimensional rotation are rotational angle theta and a position xr/yr called the rotational point or pivot point about which the object is to be rotated. The positive value for the angle theta defines a counterclockwise rotation about the pivot point. As in our figure, a negative value rotates object in the clockwise direction. We can write rotation equation matrix P dash is equal to P dot R dot P. 2D scaling, two-dimensional scaling. To alter size of an object, we apply scaling transformation. A simple two-dimensional scaling operation is performed by multiplying object position xy by scaling factors xx and sy to produce transformed coordinate xz and yz. The S is a 2 cross 2 scaling matrix. Any positive value can be assigned to the scaling factor Sx and Sy. Values less than 1 reduce the size of an object. Value greater than 1 produce enlargement. Specifying a value of 1 or both Sx and Xy leaves the size of an object unchanged. When Sx and Sy are assigned the same value, a uniform scaling is produced, which maintains relative object proportion. Unequal values of Sx and Sy result in differential scaling that is often used to design application. Some system negative values can also be modified for the scaling parameters. This only resizes an object, it reflects it more one or more than the coordinate. Other two-dimensional transformations such as reflection and shear. Shearing distort an object along one axis while leaving the other axis unchanged by multiplying the x and y coordinate of a vertex a shearing factor. Reflection flips the object across a line, hanging the sign of either x or y coordinate of each vertex. Thank you from my side. All I will like to say that video assignments are really good for learning, and thank you for being till the last, and thank you for everything.